Hey, this is Mr. Beckstrom, and today I want to look at a sample problem from section A7. This is complex numbers, quadratic equations in the complex number system. So in this section here, we're going to be trying to find complex solutions to these quadratic equations, which will often come in the form of imaginary solutions. Remember, the complex number system includes both reals and imaginaries. So a lot of times we're going to get negative discriminants from these problems, which kind of indicate that we're going to have imaginary solutions. So let's take a look at this one, and we'll look at one way to solve it. So we have a quadratic here, x squared minus 10x plus 29. 29 is a prime number, which means that we're really not going to be able to factor this easily or at all in order to get a negative 10 here. So I'm going to use the quadratic formula, but first I'm going to check the discriminant. Remember, the discriminant is b squared minus 4ac. That's the part that goes under the radical in the quadratic formula. So this is going to be negative 10 squared, which is 100, minus 4 times 1 times 29. So it'll be 4 times 29, which is 4 times, put a calculator so I don't make this mistake, which is 116. So this is going to give us a discriminant of negative 16, which indicates that we are going to have imaginary solutions, because when you try to take the square root of a negative number, we have to go to the complex number system in order to do that. So now when we look at our quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, this quadratic formula is going to give us our two solutions to where we get our zeros of our function. Normally it's where the graph would cross the x-axis, but in the case of imaginary solutions, we're not going to have a parabola that crosses the x-axis. So putting everything in here, negative b, so that's a negative of a negative 10, so that's going to be 10, plus or minus the square root of, we already worked out that discriminant earlier, so that's negative 16, all over 2 times a, which is 1, so all over 2. So then we're going to just kind of work this out. So this is going to be 10 plus or minus, and negative square root of negative 16, we can write that as 4i. And we looked at previous videos on how to do that. This is really just the square root of 16 times the square root of negative 1, and the square root of negative 1 is equal to I, and the square root of 16 is equal to 4, and all over 2. Then I can kind of break this up into two fractions, or divide both of these top values by 2. So this is going to be 5 plus or minus 2i. And so those are our two solutions. So we have the first solution as 5 plus 2i, and the second solution is 5 minus 2i. And one thing, if you keep going in math, you'll find that whenever we have imaginary solutions in any polynomial, not just second-degree polynomials, but whenever we have imaginary solutions, they come in these nice conjugate pairs for us. And that means that you're going to have a number plus a number, and then the same number minus that same number. And that's it. If you have any questions, let me know, and I hope you have a great rest of your week. Thank you.